All right, Francisco, do you want to introduce yourself?
Sure. My name is Francisco Cervantes. I'm a program manager with the Center for Computer Science Education at the College of St. Scholastica. Just recently joined the team, and previously I worked for New York City's Department of Education CS for All team as Director of Academics, managing their training and high school or scope and sequence.
So basically, Minnesota just got a huge upgrade because we still need this company. I'm Lana Peterson. I'm the PD and Community Engagement Coordinator at LT Media Lab, the University of Minnesota, and I help organize our pre-service teachers, and then I do some work with Minnesota school districts related to computer science as well too. So we have the notes, shared notes for our session where we've included a lot of the links to what we're going to be sharing about. We thought both of us would just do like a quick primer on our favorite resources on related to these topics, and then kind of open it up to see if it sparks anything in your brain as we're talking and those things. So here's also the links. We put them in our slides as well. So some of my favorite resources related to scope and sequence is CS in SF. So Computer Science in San Francisco.org has a huge library of resources related to this, and they've also kind of outlined their scope and sequence based on the K-12 CS framework and the revised computer science frameworks as well. A lot of the schools that I work with that are interested in doing computer science, especially at the elementary grades, are really leaning upon this website and creative computing for an idea of where to start and then adapting based on their personal context. And so I often refer to this just as a grounding and kind of seeing where, especially what skills maybe students would be learning at the elementary level and then how that would build upon itself. And so how can we ensure that the rigor and relevance is still there?
And I think this is a really, going off of that, it's a really good document. I don't think there's any other map like this out there that really maps a lot of opportunities, a lot of kind of things in one place. It doesn't necessarily have a formula for how to find your way, but this is a map, I guess, by grade area, by standard. It's really good to, I think, a big view of what's possible, what's out there.
And I believe because it's NSF funded, that's why it's all free and available on the website too. So
Nice.
be sure to, copy and make copies of whatever you want just in case it changes or goes down
Yeah.
for whatever reason. Oops, I think I went, never mind. The next one that I use a lot when working with school districts is the CS for All script framework, which is it's a rubric tool, and it covers these 5 areas: materials, leadership, teacher capacity, partner, and community. There are a group of us that are script trained, so to guide you through this rubric and a training related to this, but really this is like the first self-assessment that a school or a district would do when you want to build a scope and sequence to see what do we have, and then what does research say that we need to really look at in order to build an equity-based, sustainable scope and sequence for our district. And so it's really that first self-assessment that helps you build some goals related to this. And I know myself and then Jen Rosato, which is on another, she's in here somewhere, not in this call, but another call, have been trained on this framework as well if you're interested in doing more on this. And related to that, so one of their first activities that they have schools do is a visions activity. And so the link to the visions activity is here, but it's basically like when you get a group together, both CS people and non-CS people, why do you even want to do computer science? Why is it important to you? And it kind of grounds everybody in a common vision for computer science education. And then the trick to the activity is actually that there's no option to say CS doesn't matter. So just so you know, but
Yeah.
you could use this in a non-script workshop as well.
I think this is one of the questions that Tom asked, like, how do you get started? And I think there's a bunch of resources out there. Attending a training is probably the easiest thing. I think the hardest thing is getting everyone on the same vocabulary, same vision, same goals. What are we going to do? What do we have? And then really just, it's like, so it's getting them on the same page. And I think what the script team and the CS for All team has found that if everyone's on the same page, you're more likely to have a better outcomes, right? And if everyone's kind of all over the place, I define CS this way, then it's going to be, you're going to stumble across the way.
So one of the places that we've used this, Bloomington Public Schools is just beginning a large scope and sequence for computer science education. I've included some screenshots of their beliefs and their goals here. And they've started, especially this year, in elementary, because a lot of schools are focused on what's offered in high school, but if you really care about equity within computer science education, it's important for exposure at a young age. And if you look at their goals related to elementary, the first one is will provide all students, but the second is generate excitement about computing. So we're not trying to create students who can code an app by the time they're in 5th grade, but just that they see themselves as computer scientists and believe that this is something they can do. So when they're offered those electives in middle school and high school, that they have some experience with computer science and have the belief that they can succeed in this area. And so they actually started with immersion schools. So using kind of a computer science coach to co-teach with teachers to get them feeling more confident in the content area and the pedagogy of computer science. And then really used a lot of the CS and SF creative computing curriculum and adapted it to their area to start this work. And so students get one computer science lesson a week that is co-taught. And then one other thing that I love that they're doing is they bring together monthly meetings across the district. And so they have an elementary, middle, and high school group that are all meeting together, but then also do breakouts so that there's a lot of buy-in and input to the model as they're building up and growing together too. So I think that's one shining light in our state. And then another area or school district that I think is doing a really good job is Minnetonka Public Schools. Has a great scope and sequence K through 12. They have a lot of classes at their middle and high school. If you check out they have all the classes listed. And so this is just some screenshots of how they imagine students kind of cross-pollinating from different areas as well too. And one opportunity I think that all high schools in Minnesota could do would be to have more introduction entry points for students that would commonly not be in these courses, underrepresented populations. And I think the best resource for this is Exploring Computer Science, which is actually a free research-based curriculum that focuses really on inquiry as an entry point for computer science. If you go to this website, you'll see all of their amazing resources as well as the research that it's based on. So I just really want to put a plug in that if you are considering building more experiences for computer science, especially at the high school, really think about ways to get students who are traditionally would be in any of your courses, including introductory courses. Use this model. Francisco?
Yeah. Thank you for that. I think those are awesome resources. I think one of the questions that I've just been struggling with is what's a good kind of size for that script? And I think as we see kind of different school districts create their own script and their own kind of vision, most likely the ones are going to develop are the ones with resources and ready to go, right? And so how does that work with just diversity and equity in the state? Do we need the state to kind of really work a script and then create the vision? I worry and I struggle that if kind of districts do that within their own, then we're going to have different definitions of a vision and different forms of definitions of equity. And so that's some of my concern. And I think part of that, and I think that's just one thing that I've been struggling, but I think that's something that I think the state and districts are going to have to grapple with. So I think, yeah, so I guess what I'm saying is the script is awesome. I think make sure to connect with other schools in your district and your state to make sure you're aligned with that. What I have in this slide is just usually when I work with schools, one of the first things that the resources that's kind of used to map out and kind of outline everything is implementation plan, right? And so this is, and that implementation plan includes some of these things that I include, and may include, may not include some of these, but I think these are some of the big things that I asked for, right? The vision for computer science education. What is your vision? And part of the script is really helpful in identifying that vision, get everyone on the same vocabulary, get everyone on the same board. And so that's great. The next thing is the goals. What are your goals? And so think of this as either an aim statement or not necessarily a SMART goal, but this is really what you're going to be held accountable to. In New York City, and this project I'm working with right now with schools in northern Minnesota is to set goals at elementary school level, middle school level, and high school, right? So what are those goals are is that every student in elementary school will experience at least one computer science unit by the time they leave elementary. At middle school, every student will experience one course. In high school, every student will experience one course, right? And so that's setting the bar for what you want to come back to 2-3 years from now and say, have we met the goal? And it also sets, and I think these goals is an opportunity to make that your target audience, right? Who is your target audience? Who are you going to meet in this scope and sequence? And I think once there's a vision and a kind of goal of this is where we want to go, this is how we're going to measure or hold ourselves accountable to, I think then you can move into like looking at curriculum and how does that curriculum fit within those different grade bands. There's a bunch of curriculum out there. And so this really helps kind of identify that, right? And so, and some of those goals may change throughout. Some of those benchmarks may change. And I think some schools will go beyond that, right? And how you define a unit, what's a computer science unit, how many hours, right? So New York City defined that as 15 to 25 hours. That includes an assessment, at least a number of concepts, number of practices, right? And so going into the framework, computational thinking framework, but really being able to define that so everyone's on the same page about that, right? So at the end of the year, at the couple of years, we don't say, oh, that was a different, I thought we were doing this. Or 50% of my students who happen to be white and male experience a computer science unit, right? That's a great kind of moment of mirror to look back and be like, why are we not reaching every student? And so the big goal is that every student will have an computer science experience at every grade band. This might be too much, it's up to you, but set your goals right away and make sure that you're clear about those. I'll put a link to a draft scope and sequence and curriculum. And let's see if that works. It's a beast of a document. I'm not gonna lie to you.
Want me to open it in here?
Yeah, let's go for it. Let's see if that opens. And so this is just a draft, and this is a working draft. I've been working with 2 schools in northern Minnesota on building a scope and sequence. This is a link also in your document, in the notes document. I'll put that in the comments. And so what we've done here, this is after setting our vision, after setting the goals. I visited each school, elementary, middle school, and high school, and these are multiple schools, and took stock of what teachers were doing and what programs were available, what programs were being implemented. And then also got a sense of what themes existed. So if you are, this is not the case, but if some schools are tech focused, computer science focused, they're even testing students when they're coming in, every student has an algebra has completed algebra by 10th grade, right? So that's gonna be different. And then there's other places where that's not the goal. Perhaps we don't have any AP programs. And so part of this process is identifying, looking at themes, looking at assets at the school, and then really mapping those out and building that. And so this document, what it shows is curriculum at the top, and CSTA standards for each grade band, the computational practices, which are linked at the top. That doesn't mean that it's just one grade band, but it's kind of where they're introduced or where they're heavy on programming environments. So this also means that our hardware and IT team needs to be ready. And so just kind of mapping those out. And then how might that curriculum be integrated, whether it's going to be integrated within some of the activities, or whether it's going to be a standalone, right? So that's also another decision to make. And so what this shows is it's kind of like that San Francisco scope and sequence. Imagine I started with that, and then I looked at what the school had, and then I brought them together into this document to kind of create a pathway and alignment of that, right? This doesn't mean that this will work for your school. This works for the 2 schools that I'm working with right now. One thing you'll see here is STAR-based program. So this is a base. This is a Navy-based program. It's kind of like a outreach program that Navy base in Duluth area does, and they bring on students, and then students kind of week-long experience using Spheros, right? So I mapped out some of the CS standards because you're doing some of that work. Let's do that. And so what they don't know is later on we're going to do some assessment to see if students are kind of walking away with that. But at least we kind of put our stake in the ground, right? We kind of, this is what it should be covering. And if we're taking students away for 40, 30 hours of the day. We should be looking at what those outcomes are, right? And also, this also allows us to leverage existing assets. And so that's why StartBase in there. Twin Cities has a StartBase program as well at the airport. And so that's what I'm trying to do here is leverage stuff that are already doing, because every school is a lot of schools have kind of started or doing some STEM work and engagement with CS. And so I just want to call that out in this map. And so this is a draft working document of that. I put links to the curriculum and activities at the top. And then in the slide, I also put a link to, that should take you to the New York City blueprint. And then if you can click on the curriculum catalog for me. This has a lot of resources. This blueprint website is probably a little bit less shared from the CS for All team. I don't know why, but this kind of has curriculum links. This is free curriculum for each grade band. I would not ask a school to pay for a curriculum because that puts them on a subscription plan, and that makes it a little bit sometimes harder for students to access. And so this is just really, this is free curriculum by grade band with different themes. And so the training was also provided for this curriculum, but this is really links to all of the stuff on there. And some stuff works, some stuff doesn't. You'll see ECS and really kind of integrated curriculum. And so when schools want to build a computer science program, when teachers come and interested in participating in training, I want to know what background, what interest you have. You don't need to have a computer science background, but if you're really love design and sound, or let's work on computational media, right? So I'm really kind of building off your themes and your interests, not necessarily your capacity for CS or tenacity for technology. We'll build that, right? But I want to build off your love for art, right? That's really going to drive a curriculum. And so as you look at that curriculum, don't look at, oh, we'll have our math teacher who has a computer science degree do this curriculum, right? That's going to be helpful. But look at teachers who are really interested and folks who are really interested. Look at some of the projects that you're really leveraging, some of the programs that are really taken off, and then build off of those. So for example, at one of the schools, they have a music program that's going. And so one of the goals is to have a course where the students create visuals for the band as they're performing during the pep rally in high school, right? So that's really able to build off of some stuff they're doing. So that's a link to the curriculum up there. And then part of what I think is also should be included in the plan to implement that scope and sequence is a professional development model. So this is going to be a training. I like to do, I prefer pre-course or unit training. That's something before you get started. And then I think school year support is part of that. Rule of thumb, every principal asks me how many hours should teachers be completing before they implement a unit. And usually that is about 50 hours is my rule of thumb, and that's a sliding scale depending on your background and interest. And so that's 50 hours roughly for for a course. So 54 hours of computer science instruction is roughly about 50 hours of training for me. I think computational thinking framework is super important because in a couple of years from now, testing and assessment will come down the line, and you should know what what learning outcomes are for each curriculum, right? Standards, of course, CSTA standards are pretty much the lead and one of the focus on that. We don't have state standards yet. Am I right on that?
No, we don't.
So somebody hurry, light that fire. We need that because I think what's going to happen is everyone's going to do their own thing, and then we're going to have to come back again and figure that out. And so I think hopefully it looks like they're going to be really focused on CSTA, but that's a big piece to keep in mind. And then a school technology plan. A lot of schools already have a technology plan. Some schools don't. And so part of that is we're going to be introducing hardware. We're going to be using student accounts. How do we maintain that? Where do teachers know for support? And so sometimes I think that's part of implementation plan. You can implement a scope and sequence without kind of a connection with IT, and that's hardware and software. So I think to me what I wanted to show in the slide is how the scope and sequence fits between the implementation plan. It's an important piece, but it's not all of it, right? There's so many different kind of pieces and elements to this. I didn't go into hardware that much because I really want to focus on the kind of the standards and what's going into that. Read through some of the comments here, and then I think we can go to the next slide. yeah, they do provide a whole different beast of standards. Yeah, I think I think that's part of that vision. I think that expect a state to also kind of deliver on that. But I think, yeah, it's one for vocabulary, so we're all on the same page, and also what we're holding ourselves accountable to.
Minnesota has taken the strategy of embedding computer science standards within some of the other core content areas, but without really any directions or professional development to support what that means. And so it's a little bit of an area of confusion right now, and has said that it would take an active legislation for them to add computer science standards.
Wow, thanks for that, Matt. I think I love the idea of integrating into other subject areas. I think it's just how that gets done is very different, and then who's held accountable to that. But one of the in the scope and sequence document, you'll see that integration happens in the younger grades. I think that's a great opportunity for that, partially because I really worry about taking time away from other core subjects, and I think that's and I think so that's in a big part. In middle school, a lot of schools are interested in digital citizenship, and I think that's a great opportunity for that, weaving with CT. And then in higher grades, folks are interested in kind of heavier, more syntax-based programming experience. I worked with a lot of the AP Computer Science Principles program in New York City. I got a little disillusioned by the AP system. But I think some schools ask students to provide that AP Computer Science program at 10th grade, and these are technical schools, and so that scope and sequence really kind of it depends on what you're trying to do as a school.
So we have about 5-6 minutes, Tom. Am I right?
Yeah.
Yep. That sounds good.
Is there any things that people want to talk about? Questions that haven't been answered? Ideas, resources. Annie shared Dr. Carol Fletcher, who is pretty much like a superstar in the computer science research world. Texas is a lot farther along in teacher licensure as well, which is something that Minnesota really needs to get on board with. And so it's a little bit clearer. There's a clearer path and more resources and professional development for how you would become, like, if you're an English teacher and you want to have your computer science license as well, how you could make that happen. That's another thing Minnesota really needs.
Yeah, and if it sounds like folks are coming from different states, so what I would suggest is if you're interested how that works, look at the last subject area that became licensed in your state, and see how that was done. Right, that's most likely what states are going to use as a model for creating that licensure. In New York, the last grade was PE, physical education. And so what happened is that physical education teachers were trained, or math teachers were trained as PE teachers, and then the state later on gave them a certification because they had taught PE for a certain number of years and received training. Right, so really I think part of one way to look at that is look at previous grade bands and look at our previous grade subjects and look how those subjects and the training. So I don't know, I'm not entirely sure how Minnesota did. Yeah, MA really set that standards and framework from the start. And I think part of it is it's a lot of work to identify the standards and framework as a district, as a school. It's just a lot of work, and I think I'm worried that it's about that right fit from bottom up to top down.
Renee asked, does anyone on the call have experiences with the processes in their district, successes, challenges?
Yeah, I could share a little bit. So I work at St. Paul Public Schools, and it's a pretty large district in Minnesota. And last year, there was kind of like a team put together for computer science integration, what that would look like. And to be honest, it was just kind of a challenge. And I think a lot of the challenge has to do with like the size of the district and trying to get as many invested parties as possible. Instead, it kind of seemed like a pretty small task force that they put together, and it really depended on who was sharing or speaking or taking the lead as to like what direction the work kind of went. And so my understanding now is that team's still kind of meeting, they're still kind of trying to refine things, but to be honest with our district, it seems like a really, really long process. I believe they shared something like a couple years of developing a plan, a couple years of piloting it at like a certain location, then a couple years of like refining it and reviewing that. So it's a daunting process. So it's kind of seems like it's a struggle, but also I don't know how else to do it that's not really a struggle at the same time,
Yeah.
So that was just kind of my experience with that team as well in St. Paul.
Thanks, Tom, for sharing that. I think one of the challenges that I also foresee in the future, and I think this is just for all schools, and I think St. Paul, I think, has a little bit harder because how districts and schools count for time spent on certain activities varies. And so I just recently learned that St. Paul doesn't report on that, on the time spent of activities. So later on, as I was saying, setting up those aim statements in CS for All, how do we then go back and say like, oh, these group of students experience this number of hours of CS, right? And so I think leverage existing measurements, existing data, existing systems to then measure that amount of time on CS, right? And I think how that happens, I think that's also very time consuming, right? And most systems are outdated in school districts, but after we roll out programs, how do we know what we did? And how do we keep track of that across years, across schools? That is a big challenge. And if that is not set up in place, then I think it kind of leaves room for inequities.
Rick
shared
in the chat about a virtual class. Do you want to unmute yourself and share any more about that?
So this is Alicia. I work for the Minnesota Virtual Academy, and I was part of the coding cohort last year, and I asked the school if I could teach a computer science class, and they let me. So I had to.
Nice.
They said, find your own curriculum because we don't have any. So I spent my summer searching, and I stumbled across that computer science in San Francisco curriculum, and I just did, because the way that our school is set up, I could have a variety of students, 6th through 8th grade. So I did my CS course that was primarily built in Scratch, and so I adapt it so that I could put it into our learning management system, so students could go through without having to go to a different website. So I spent a lot of time in the summer doing that, and even into the school year, but it went really well. And I had a lot of students sign up for it. Out of our middle school, like 400 students, with 7th and 8th grade, I had 40 some in each. There was just one section each offered each semester. So it went really well. And they said I could teach another class this next year, like a year or two. So I looking for additional resources for that. But it's been kind of interesting now that everybody is distance learning, because when I first started with this, there just wasn't a whole lot out there for kids to do virtually. So even just in general teaching with math, I'm excited because now everybody is sharing a wealth of resources for what they can do virtually, and before we're just kind of coming up with our own. So it's really exciting from my perspective, to have this. I'm sure all the traditional teachers are ready to go back to the building, but I'm excited to have more resources to work from.
Awesome.
Absolutely.
You're also reminding me, I just shared a link in the chat to a tech rubric, and it's for evaluating. It's by the Canon Lab, so evaluating CS curriculum. It's heavy. It's pretty intense. I think it'll take you several amount of time to get through that, but this is like one place. How do you know what's a good curriculum? Not all CS curriculum is created equal. And I know that's sometimes hard to hear, but not every curriculum is created. So, and then not everyone's going to give you a good fit. And so this is sometimes helpful for evaluating that. And I think you mentioned 6th to 8th grade. that is, I think, is such a great sweet spot. If you're implementing a scope and sequence, start small. Don't roll it out to every grade band. It's going to be a struggle. Start with one grade band, and I would suggest middle school because you learn so much from that middle school grade band. It's also doesn't have as much high stakes because you're not influencing high school. You're gonna have to introduce a course, mess with the schedule. It's a little crazy. Middle school tech integrationist is my strategic kind of sweet spot, and I prefer to kind of work there before working with elementary school because then we get a sense of like what the pacing will look like, what our students reacted to the curriculum. I think to me that middle school is a flexibility. And so that allows for you to learn the most and it's the most flexible, right? And so and then elementary school teachers, I don't want to waste their time with kind of these first year struggles. I would much rather bring them in later on because they have so much to do in such little time. Oh yeah. Yeah, elementary curriculum is probably the least amount of good CS curriculum that I see. There's a lot of things, a lot of robots, lots of stuff, but really good curriculum is different. I know it sounds like we're over time, but feel free to take any more questions.
Thanks, everyone. Try to put all these in our document as well, too.
Yeah, sure thing. We have our email on this document, so feel free to reach out with more questions and resources. We're happy to share those out.
Thank you guys for sharing.
Cool. For sure. Have a good time at the conference. See you folks.